Okay, so multiplying by tens helps us multiply by bigger numbers, like 100. Let's just go back to our number system and think about this. So we have 10, and then we have the next bigger number in the next place, which is 100, or 10 times 10, which is 100. So I'm going to keep track of this. 10 is equal to 10, 100 is equal to 10 times 10, 1,000 equals 10 times 10 times 10, and 10,000, or in this case 1, 2, 3, 4 zeros, is equal to 4 tens multiplied. You might see a pattern here. We'll do a couple more. And then after 10,000 we have 100,000, or 1, 0, 0, 0, 0, 0. In this case 5 zeros, and that's 5 tens multiplied by each other. And then we have the next number, a million, and that's 6 zeros, so that equals 6 tens multiplied by each other. 1, 2, 3, 4, 5, and then 6. And notice, let's go back to the very beginning. So we had 10, that's equal to 1 tenner itself. And then 100, which has 2 zeros, is like a 10 times a 10. And then 1,000, which has 3 zeros, is just 3 tens multiplied by each other. And then 10,000 is like 4 tens, or because there's 4 zeros in the number. And then 100,000 is like 5 tens multiplied. And a million is, well, 6 tens multiplied by each other. Now the place value in these numbers, again, goes every 3 digits, if you want to go back and put the commas in to help us see what's happening. And these tens help us build these numbers. So how does that help us? Well, if we go back to this problem right here, 42 times 10, well, the pattern in tens is 42 times 10 gives us 42 and a 0, or 420. Well, if we look at our chart right here and think about what 100 is, that's like 10 multiplied by 10. So it's almost like thinking about this problem as 42 times 10 times 10. So we're multiplying by 10 twice. So what would happen? 42 times 10 would give us 420, and then 420 times 10, well, again, we're going to take that original number and multiply by 10, so we'll have another 0, so we get 4,200. So instead of doing these two steps, when you see 42 times 100, we can then think of this as 10 twice, or 42 and 2 zeros. Likewise, 42 times 1,000. Well, this is like 42 times 10 times 10 times 10. And every time we multiply by 10, we have another 0 added onto our original number. So what's going to happen here is we have 42 times 1,000 is really just 42 and 3 zeros, or 42 1,000s, which is what this number says right here. Knowing this, we can really deal with any problem, especially whole number problems. 513 times 100,000. Seems nasty, but if we think back, 100,000 is just, well, count the zeros, 1, 2, 3, 4, 5 zeros. So it's like taking 513 and multiplying by 10 5 times. So every time we multiply by 10, we add another 0 onto 513. That's how our place value works. We're making the number 10 times bigger 5 times. So this would be 513, our original number, and then 1, 2, 3 zeros. Every time we multiply by 10, we get another 0, 4, 5 zeros. So just count them, 1, 2, 3, 4, 5, and then you can put the place value in every 3 digits. So we could read this as 51300,000, or 51,300,000. So you can find the tens in any of these big combination problems. Think about a last example. Okay, 1,201 times 150. Well, this would be easier to think of if we took 1,201 multiplied it by 100, and then thought about the 50 that's left over here. And the way I'm going to think about that actually is 50 times 1201. This might help us. Well, 50 is half of 100, so 1201 times 50 should be half of this. And that might help us. So 1201 becomes 1201. I forget the comma for a moment and think, well, 100 is 10 times 10, so it's like multiplying this number by 10 twice, which gives me 2 more zeros. And I would go back and add those place values in to help me keep track of this, and that's just 120,100. Well, 1201 times 50 is half of that. How do we think about that? Spread the number out. This is 100,000 plus 20,000 plus 100. This is less intimidating to me. Half of 100 is 50. Half of 20,000 is 10,000. Half of 100,000 is 50,000. So now, 50,000 plus 10,000 is 60,000. Plus 50, that gives us this number. So 60,050. And now we add these two numbers together. So 100, I'm going to think about this for a moment. 120 plus 60 is 180. And I know it's going to be 1,000, but I forget that for a moment. That's a big number to think about. And then we have 100 plus 50. So our answer right here is 180,150. Now that was a lot of steps, but I like this because it helps me keep track of what's happening with these numbers. You could write them out in 2 columns and then break it down part by part. When you break numbers apart and think about the friendly 50s and 100s, it feels just more manageable as a problem. It feels like something we can really deal with.